Welcome to today's webinar. I see that people are still joining. We can give them 2 minutes and then we can start. We start at 2 minutes past 15:00 Nairobi time. So thank you very much for finding time to join this sixth and final webinar in a 6-part series of webinars that we have held since May this year. My name is Hezekiah Pire. I lead the water and sanitation team at the global headquarters of UN-Habitat here in Nairobi, and I will be your moderator in this webinar. Now, UN-Habitat has partnered with the Water and Sanitation for Urban Populations, WSUP, and SANDC EWAG, the Department of Sanitation, Water and Solid Waste for Development, at the Swiss Federal Institute of Aquatic Science and Technology to develop an online masterclass with 7 videos and to convene these seminars to disseminate the findings and recommendations of the UN-Habitat Global Report on Sanitation and Wastewater in Cities and Human Settlements. Now, we have recordings of the previous webinars that we will be showing you how to get. And then this webinar is also being recorded, and all the slides presented in this webinar will be shared with all of you who have joined today. Now, this final webinar is based on Chapter 9 of the Global Report, and Chapter 9 focuses on emerging innovations to support a more circular and climate-resilient sanitation systems. So this is the series of webinars that we have held so far, beginning of 8th May. And let's go to the next slide. So today we are joined by distinguished speakers composed of global experts and practitioners, and I will be introducing them as they speak. Next. We will be starting this webinar with an introductory presentation by Gertrude Salano, and Gertrude is a sanitation lead at Water and Sanitation for Urban Populations. Gertrude has 27 years of experience in the sector and has led multi-sectoral urban water and sanitation projects. And Gertrude will have 8 minutes to do the introductory presentation. After that, we will have a case study from Hanoi, Vietnam, by Thuy, and I will be introducing Thuy as she speaks. Then that will be followed by reflections from Hamburg, which has a very good experience with innovations around wastewater. That will then be followed by an expert panel, and I will be introducing the panel when their time comes. So just housekeeping issues. We have a Q&A on the screen. Please use the Q&A for questions to the speakers and the panelists. The speakers and panelists will either directly respond to these questions in the chat, and some of the questions will also be put to the speakers to respond to as they speak. Please keep your questions relevant to the topic of the webinar. This is important. And also feel free to use the chat for comments. Like I've mentioned, the webinar will be recorded, and the slides and the recording will be shared with you. So over to you, Gertrude. You have 8 minutes.
Mm-hmm. Thank you. Thank you very much, Pire, for the introduction, and I'm glad to be participating in this webinar as a presenter. So I will be presenting a summary of findings from Chapter 9 as alluded by Pire, and this is focusing or giving insights on wastewater and fecal sludge reuse. Then it's looking at the climate resilient sanitation systems. And then lastly, then mapping out what does then the wider innovations in wastewater management look like. Next slide, please. So according to the report has clearly mapped out the byproducts that are affiliated to wastewater and fecal sludge treatment. And this is clearly illustrated in the figure that is on the screen, which is actually evidencing the shift that we now have. We are moving to a circular economy that seeks to transform wastewater and fecal sludge into economic resources and benefiting several sectors, including energy and agriculture. And a good example is actually from Hamburg City, and where energy is being recovered as biogas and biomethane, and we'll have this presented as a case study after this presentation. Next slide, please. So as per the report, wastewater reuse is really contributing to solving the global water crisis. And in the report, it is clear that treated wastewater offers a sustainable alternative to costly and environmentally damaging water infrastructure, as it's coming in to really help and meet the needed water demand. And we have seen wastewater being used for non-potable reuse to support agriculture and industry. And Israel is such a case whereby 90% of its treated waste is reused for purposes of agriculture and industry. And then also potable reuse is growing and gaining traction, and can be attributed to advanced technologies like reverse osmosis, which is treating the water into acceptable and permissible standards. And this practice is actually seen in countries like the UK, the USA, and Singapore. And unfortunately, portable reuse adoption still remains low or not non-existent in low and middle income countries, and this can be attributed to existing barriers like financial constraints and lack of treatment infrastructure. But it's worth noting also, untreated wastewater, yes, remains widespread, but also it's characterized by health risks, and thus strong regulations and safeguards are very essential to guide this. Next slide. From the report, then, it is clear that we are moving towards a circular sanitation economy, and we have entrepreneurs who are advancing such fecal sludge management, and this is being done through off-grid circular sanitation systems that are seeking to recover nutrients, energy, and water. The report then also highlights container-based as a potential technology that can be used especially for the population that is densely populated, areas that has dense population. And we will have CBS Alliance, we'll have Remy from CBS Alliance. He will also speak to this and give more insights on the same. Next slide. Now, in the report, climate resilient sanitation systems are clearly articulated, and innovations on the same have actually been reined in. And it is, we are aware from the report, it is clear that sanitation is already affected by climate change shocks like flooding, droughts, and rise in sea levels and extreme weather, thus causing infrastructure damage and a rise in health risks. So the report outlines key principles that then chart the way how then do we move into resilient systems, besides infrastructure adaptation measures, which include elevated or flood resistant toilets, especially in the flood prone areas, and using water saving technologies like the container based sanitation, and good practices like climate resilient urban drainage, which are technologies that are across cities in the world, Hanoi, Shanghai, and Hamburg. So we will have a case study from Hanoi to give great insights on the same. Next slide. Enabling a climate resilient sanitation systems then calls for policy instruments to be put in place, practice and finance innovations. And unfortunately, as per the report, financing that is going to sanitation projects continues to remain low, and the report looks at the nationally determined contributions from different countries, and unfortunately sanitation still remains, the focus on sanitation still remains low. And as per the report, only 2% mention sanitation access and only 3% is addressing wastewater. So this is really evidencing how then investment to sanitation still remains low. But there are also good practices. For example, the real world innovation in which is practiced in Etiquini, South Africa. Next slide. Now I will look at the innovations that around wastewater management. And one such innovation is the wastewater-based epidemiology, which is an analysis of we're analyzing wastewater and really seeing then how is it interacting with the population health and behavior. And glad to report that World Health Organization has offered guidelines on this, and we have Kate will actually give further insights on the same later on in the presentation. Next slide. There are other innovations when it comes to wastewater treatment, and the realization that we now have an entry of new pollutants, which then calls for different approaches when it comes to treatment of wastewater, and that thus driving information for the same, innovation for the same. And also the existing other technologies, and these include membrane technologies, microalgae systems, microbial fuel cells, and the use of the UV disinfection, which is a safer alternative to chlorine. Next slide. So what then does the key takeaways from the report look like? It is clear that wastewater is being reframed as a valuable resource. And it is clear that it is enabling the reuse of potable and non-potable purposes, thus calling for a clear regulatory safeguard that then guides the SIM. And then two, it is very clear that the circular economy models for fecal sludge are emerging, and the container-based sanitation is leading in such innovation. So then thinking should be, how do we then take this to the next levels? And then three, I have talked about the climate resilient infrastructure, and from the report confirms that this is gaining traction, and this includes having flood resistant or climate change shock responsive infrastructure and systems. And then wastewater-based epidemiology is also an innovation that is coming in and offering a cost-effective tool for public health surveillance, especially in the law in the law testing environment. And then lastly and conclusively, the report has alluded to the fact that decentralized fecal sludge treatment is critical, especially when it comes to closing the service gaps for the low and middle income areas. And thank you very much for listening to me. Over to you, Pire.
Thank you very much, Gertrude, one, for keeping the time, and two, for giving a very comprehensive overview of the findings and recommendations of this global report. We now have an audience poll to engage with you, and this poll will be administered by Sam Jabal. Sam, I know that you will not introduce yourself, so let me take the privilege to introduce you. Sam is the Director of Research and Evaluation at the Water and Sanitation for Urban Populations, and is one of the main authors of this global report, and also the masterclass that has been produced together with Sunday Ewag. Over to you, Sam. We have 2 minutes for the poll.
Great. Thank you, Pire, and pleasure to be here. And thanks to all of you for joining this final webinar. So through this series, we've been running these polls just to test if you've been paying attention to these presentations and to Gertrude's excellent overview there. So if we can bring up this first poll question. If properly managed, recovered products from wastewater include... Now, I'm not going to give you long to answer this, but I am going to read through so you have at least that time. Treated wastewater for possible reuse, biogas and biosolids for energy production, antibiotics and pharmaceuticals for medical reuse, heavy metals recovered for direct industrial reuse, nutrient recovery for agricultural use, non-potable reuse, including, for example, irrigation, firefighting, toilet flushing, pathogens extracted for vaccine production, and microplastics recovered and recycled into food-grade packaging. You can tick as many as you like. Which of those do you consider as products that can be recovered from wastewater? And I've already spent long enough reading through those, so I'm going to now bring up your responses. Excellent. Thank you. And that's a very good effort, I would say. So there is a quiz that will be published as part of this masterclass, which includes more context on these questions and more details. So I'm not going to go through it here, but there are 4 correct answers, and the majority have identified each of those. Treated wastewater for possible reuse, as Gertrude outlined, biogas and biosolids. We'll be hearing more about that as we move through. Nutrient recovery for agricultural use, and the range of non-potable reuse. So that's a strong performance, and we'll see how you go in question 2. Back to you, Pire.
Thank you very much, Sam, for this poll. We now are going to listen to a case study from Hanoi, Vietnam. And this case study is on flood prevention via sustainable urban drainage systems. It will be presented by Tui Bui. Tui Bui is currently a research and development scientist working with Moleaer Inc. in California, USA. And she is bringing a lot of passion on nanobubble and its application for water and wastewater treatment. Prior to working with Moleaer, she also worked with Thu Lo University in Vietnam as a lecturer and a Vice Dean of Division of Environmental Engineering and Management. Tui, you have 6 minutes. Over to you.
Thanks, Pire. Hi, everyone. I'm so glad to be here sharing the case study of Hanoi, Vietnam, with the focus on the flood prevention via sustainable urban drainage system. Next, please. So let me start with the key information of the case study. Hanoi is the capital city of Vietnam with a population more than 8 million. And more than 10 years ago, the water network coverage connection is 40 to 70%. And recently it has been increased. Regarding to the sanitation coverage, it stays at more than 60%, and the wastewater treated is less than 30%. The sludge usage is very little in Hanoi City right now. It's ranging from 2 to 8%. And most of the sewerage and drainage system in Hanoi is the combined systems. Next, please. In fact, Hanoi is facing so many problems related to the poor management of the city wastewater and the sanitation management. For example, the water pollution, as the untreated wastewater has been discharged to the water bodies. And also Hanoi is suffering from the chronic and severe flooding, especially in 16 key locations across the Hanoi. And in the photo, you can see this is the flooding inside the city of Hanoi. Last year happened like May 2024. And it has been said that 10 to 30% of the untreated wastewater has been reused in aquaculture and in agriculture. So next, please. Several solutions has been implemented in the cities, focusing on the efficiencies of the wastewater and sanitation management, deploying the sustainable urban drainage system with the approach of the source control, the pathway controls. And in addition, we also focusing on the wastewater reuse in more properly way to make sure that it's safe to reuse in aquaculture and in agriculture. Also, we are taking into account with the responsibilities of the more and multiple stakeholders. And more detail gonna come up by next slide, please. The mode of action on efficient wastewater and sanitation management can be addressing by the managing the sewer and on-site sanitation for the existing system by categorize the different function and the role of the different stakeholders, from the household to the private company to the community to the people committees. And learning from the past, we are expanding. Hanoi is expanding, so we need to build and focus on the separation of the sewerage system for the new urban area to better manage the storm water for flood mitigations. So next, please. So City of Hanoi is implementing the sustainable urban drainage system using the source pathway receptor approach for flood prevention. Regarding to the source controls, we are focusing on the rainwater harvesting, the storm collection at both micro scale and macro scale. The pathway receptor control is mainly relied on the improvement of the drainage system by constructing the pumping station or like the rainwater drainage system, and as well as applying the innovative technologies in the wastewater treatment facilities. So next, please. As I mentioned earlier in this presentation, the untreated wastewater has been reused in aquaculture, agriculture, but without any treatment. And it can cause some like potential dangers and the health concern for the users. So we are putting the farmers and fishermen in the position of the making decision and in the training on reuse the wastewater, focusing on the water quality and how to reuse it safely in aquaculture and agriculture. We are also receiving a lot of support for the wastewater reuse in the national level policy, and it has been mentioned in one article of the Law on Environmental Protection on 2020. This is very, very important. It has been upgraded from the Law on Environmental Protection 2012. And another solution we are trying to put is like we want to include the wastewater fishborne in the development plans of the cities. Regarding to the responsibilities of the stakeholder, we would say that all levels are involved, from the top down, like top tier local government to the people committee, to the private organizations, some company and partnerships, and also to the household and ownership of the systems. So next, please. We also got some support and recommendation from the World Bank to try to target Hanoi as a free city for water pollution and flood by applying the different activity focusing on infrastructures and institutional and regulator to make through some like assumption to achieve the better wastewater treatment and better sanitation management, also reduce the flooding in the urban areas. So next, please. So what can be the takeaways from this case study. It has been said that the innovation deployed in Hanoi, showing the need of upgrading the citywide sanitation system for flood mitigation and pollution risks as well. The implementation of the sustainable urban drainage system can be considered by using the thought pathway receptor approach to manage the flooding and the pollution risk and to mitigate the urban flooding risk in not only right now, even in the futures. And it has been said that the wastewater reuse is receiving a lot of attention in the city development plans. However, we're still far away from the optimal and sustainable in terms of the technique and skill developed for the farmer and for the fishermen to achieve the dual objective on the aquaculture and the production of the treatment, the aquaculture production and the treatment of the wastewater. So this is like the lesson learned we have learned so far from the case study. And thank you so much, for listening. Yeah, over to you.
Thank you very much, Tui, for this excellent presentation and also keeping to the time. We will have our second poll. Over to you, Sam, for 2 minutes.
Great, thank you, Pierre. So let's go into the second question, if we can bring that up. And this is building both on Gertrude's presentation and then on Thuy-Bui's case study from Hanoi, which is also detailed in the global report. So select all correct answers from these three. Rapid runoff from concrete surfaces increase the risk of flash floods and landslides damaging infrastructure. Statement 1. Statement 2, higher temperatures and changing precipitation patterns have no effect on wastewater and fecal sludge management. And finally, cities should prioritize climate change mitigation over adapting sanitation infrastructure. I give you just a few seconds to absorb those three statements and select all of those that you think are correct. Okay, if we can now bring up the responses. Okay, so rapid runoff from concrete surfaces increase the risk of flash floods and landslides. That is true, and we've heard from Thuy-Bui around sustainable urban drainage systems as one potential response. The second statement, higher temperatures and changing precipitation have no effect on wastewater and fecal sludge management. That is indeed false. Higher temperatures and precipitation can affect treatment processes. They can also increase pathogen survival in water sources. And finally, this third statement is perhaps more complex, but I think in the view of the authors of this report, we would say that this statement is incorrect to prioritize mitigation over adaptation in the context of urban sanitation. These should be seen as two complementary and reinforcing areas. There are interventions that respond both to mitigation and adaptation. One example actually is container-based sanitation, which we'll be hearing more about later. Okay, back to you, Pierre.
Thank you very much, Sam, and also the audience for actively engaging in the poll. So the next presentation is a case study from HAMBURG WASSER. It will be presented by Karam Kodri. It is on integrated approach to energy optimization and resource recovery from municipal wastewater. Mr. Kodri is an environmental engineer specializing in wastewater management and process engineering. Since joining HAMBURG WASSER in 2017, he has progressed from a project engineer focused on international development projects in the water sector to a pivotal role in managing and coordinating water operators partnerships. Over to you, Karam, and you have 6 minutes.
Thank you, Mr. Pires. So, as you all know, sludge generation and energy consumption remain persistent challenges for wastewater treatment plants around the world. So maybe next slide, please. And the treatment of wastewater represents the largest share of energy usage, particularly due to high demand of aeration systems. And here you can see our wastewater treatment plants located on an island directly at the river of Elbe, with our sludge digesters, as well as the incineration facility to the left, which processes the treated sludge to recover energy and produce phosphorus-rich ash. So these digesters produce, of course, biogas via anaerobic decomposition of sludge, from microorganisms, contributing significantly to our energy efficiency efforts. Next slide, please. So our journey began, as you can see, in the 90s with the construction of the first incineration plant, including CHP units. And since then, we have implemented several measures to enhance the efficiency, including replacement of surface aerators by fine bubble diffusion, which saved approximately 25 gigawatt hours of consumption, as well as the integration of co-substrates from external parties to boost biogas yield. Furthermore, we have also expanded our renewable energy portfolio with wind and photovoltaic plants and built 2 gas upgrading units capable of treating. Yes, this is the incineration plant number 1, and these are the CHP unit below. You can see the 2 units of biogas upgrading capable of treating up to 10 million cubic meters of raw biogas per year, and achieve a biomethane purity of over 99% methane by removing, of course, hydrogen sulfide, carbon dioxide, and other impurities. And after undergoing in situ upgrading, this biogas is fed into the municipal gas grid, generating both energy and revenues. So approximately we use 25% of the generated biogas for the gas upgrade. These measures combined have enabled our plant to transition from being a major energy consumer requiring around 100 gigawatt hours per year, which amounts to, by the way, just for a bit of context, around 5 million euros per month for the electricity bill, to achieving near energy autarky, so near energy independence, where we now generate 130% of our demand per year, of course, in average value throughout the year, because we still need to rely on external electricity supplier during maintenance activities, which amounts to up to 10% of our demand. Next slide, please. This is a very unique plant to Hamburg Water, actually. This is the phosphorus recovery plant from the sludge ash. As you all know, phosphorus is a finite and critical resource. Its recovery is increasingly regulated via the German environmental legislation, which stipulates that starting in 2029, treatment plants with a capacity exceeding 50,000 PE will be legally required to implement phosphorus recovery measures. So in response, Hamburg Water has entered into a PPP contract with Remondis to develop and construct a pioneering pilot facility aimed at phosphor recycling from the incinerated sludge ash. The recovery process involves, as you can see, the addition of specific chemicals, salts, and processed water, resulting in the extraction of phosphoric acid, metal salts, and gypsum, which will be also further given or sold to other utilities as viable or industry as viable byproducts. So this plant is currently undergoing trial operations and expected to go fully operational by 2026, if everything goes according to plan, which positions Hamburg Wasser at the forefront of sustainable resource recovery in the wastewater sector. Next slide, please. Okay. Yeah, here I'm going to present one pilot project from Hamburg, which is also being implemented by other utilities in Sweden, for example, or in the Netherlands. We call it the Hamburg Water Cycle, which is an innovative pilot project focused on the separation or separate collection of materials and in situ treatment of municipal wastewater within the Jenfeld district of Hamburg City. So it introduces a decentralized and resource-efficient approach by dividing wastewater into 3 distinct streams, as you can see: rainwater, grey water, and black water. So rainwater is naturally uncontaminated, gets polluted over the runoff. Grey water, next click, please. Again, yes. As you can see, grey water is from household sources, excluding toilets. lightly contaminated and low in organic matter, black water from toilets rich in organic matter and nutrients. And the system applies vacuum technology to separate everything on site and forward it directly into in-situ plant, which treats the gray water and the black water separately to produce biogas, and via CHP also produce local heating as well as electricity. So the achieved goals is the separation, reduction of CO2 emission, around approximately 400 tons per year, and we generate both energy, thermal energy, approximately 250 megawatts hour per year, and as well as electrical energy, and we can reach up to 70% water savings via this vacuum technology. This is also, of course, a flexible and decentralized system adaptable to your urban needs. Thank you.
Thank you very much, Karam, and you have kept the time, and I know that some of these issues will also come up in the expert panel that we are having now. So we are now joined by 4 distinguished panelists. I have introduced Karam and Tui, and let me now introduce Kate and Remy. So Kate is the sanitation team leader within the WASH team at WHO. And in her role, she is responsible for translating health evidence to policy and practice through WHO guidelines, and for health sector collaborations where sanitation is a critical component of risk and disease control. Kate led the WHO guidance on environmental surveillance for COVID and is investigating potential for micropathogen surveillance. Remy is the Executive Director of Container-Based Sanitation Alliance. For those who are not aware, this is a coalition of innovative sanitation operators, and Remy has 20 years of experience on urban issues and sanitation, especially focusing on supporting social enterprises, developing innovative finance models, and finding what can possibly work for people living in informal settlements. Very important background captured in our global report also. So we have 3 rounds of questions to the panelists, and I will also be looking at the Q&A to look at some issues that are coming up there that the panelists could respond to. Let me start with Karam. Karam, you have presented very cutting-edge, experiences from HAMBURG WASSER with the wastewater reuse and resource recovery. And we are just wondering the potential for adoption by other wastewater utilities. What advice would you give to utilities that are thinking about testing similar innovations?
Yeah, thank you. So as my colleagues already mentioned, we have to see wastewater not as a waste, as the name applies, but as a valuable source. So you have to take into account your local context. So maybe start with, depending on the measures that you have, we have implemented several measures, including energy efficiency measures and also energy generation measures. So you have to look at your assets. You have to, I would say, conduct a feasibility study. This is the most important step, to investigate the local situation, engage stakeholders at early stage, try to see how your topography, how your geography is located around you. You have to also take into account the revenue diversification when you sell your generated or excess energy. And of course, it depends also on your CAPEX budget and incentive financing, for example, if you get some subsidies. But it remains that the most important asset is the qualified staff. So you have to have the qualification needed for these complex processes, which is not an easy task. For example, operating digestion processes, proved to be a big challenge. So you need the expertise to keep up the work and be flexible with the challenges presented in a very, very short and nutshell way. Thank you.
No, thank you. Thank you very much, Karam. Let's go to Kate. And Kate, one of the concerns really is this widespread use of untreated wastewater that the global report has highlighted. Can you tell us more about the health impacts that are associated with these practices and how can they be mitigated? And what advice would you have for a city authority that is aiming to use to ensure safe wastewater reuse?
Thanks, Pere. Actually, when I first saw this question, I was like, "Oh, reuse, is that innovation?" It's really actually something that is really so widespread, and it exists in a lot of cultures traditionally. So I think really the innovation we're talking about here is making sure that reuse is safe. And I think what we see in a lot of these situations is there's a lot of reuse happening out there that's not safe. And there's a lot of pressure actually to do more reuse for the purposes of circular economy, for climate resilience and so forth. So actually making sure that the safety agenda keeps up with it is super important. Otherwise, we're going to undermine the fundamental purpose of sanitation systems, which is to protect the environment and human health. So when it comes to reuse, I think one of the first things I'd say is first we need to be understanding like who are the exposure groups. So often the farmers themselves are one of the main exposure groups. Then you have the local communities and then the consumers of those products, and they may be local or regional or international consumers. And then similarly, they're exposed to sort of pathogens and chemical risks. We're largely concerned about some of the pathogen risks that lead to foodborne outbreaks or gastrointestinal issues within consumers and farmers. The chemical risks often accumulate over a longer time within the soil. But really, I'll put it in the chat because there's a lot. We have guidance on safe use of wastewater that's rather old now, implementation advice through sanitation safety planning with a lot of training materials associated with it. But some of the key sort of concepts that are in there is really thinking about water quality fit for purpose. So looking at what type of use and what are the exposures related to it. So, and not relying entirely on wastewater treatment, but looking at multiple barriers. What can we do with treatment? What can we do on farms? What can we do in markets to reduce risks? And understanding that reuse is a dynamic process. Sanitation systems are dynamic, so that needs to be an ongoing risk assessment and management approach. And also recognizing a lot of this happens informally or outside the mandates of different entities. So we need to make sure that the sector coordination actually takes on responsibility for all parts of the chain where reuse is happening, and not assuming that reuse can be a profitable standalone business. It needs that oversight, it needs that government coordination and stimulus to actually work as a safe enterprise. And then finally, just to add, like lots of sanitation things are like hyper local, but if we're talking about exporting produce, fish and other things, we're also interacting with international markets and understanding the requirements and regulations of those different markets we might be exporting into. So there's a lot there, but I'll pop these links in the chat and pass to the next panelist. Thank you.
Thank you very much, Kate, and we will have an opportunity for a second round of questions on this. So let me come to you, Remy. I mean, we've heard about the potential for wastewater reuse, but there's also movement towards creating a circular economy of fecal sludge. Now, how are container-based sanitation providers working to promote these approaches, and what do you see as their potential, both commercial and environmental?
Thank you. Yeah, I get people who know me know I get very excited about sanitation, and one of the things that is very exciting at the moment is the reuse aspect. There's a lot happening in that space, a lot of innovation, and there's new products. We know about compost, but there's also things that are less evident, like biochar, which can capture carbon in the soil, animal protein that can replace animal protein made from fish, for example. So if you get the larvae of the black soldier fly, they love to eat fecal sludge or decomposing organic waste. It's amazing. So you can do a lot of things. If you separate urine, you can enrich your biochar with urine and add more nutrients. Really, it's a very dynamic space, and if you're a young professional working in that space, you should definitely keep an eye on everything that's happening. So there's a potential to create a circular economy because there is income that's possible from there. You can have revenue from many of these products, and some of them can attract interesting revenue. It won't be enough for the whole funding gap. And like Kate was saying, it's you will still need a lot of government leadership and involvement. You won't make a wonderfully profitable business just out of this, but it means that you can reach, you can go towards universal access for sanitation at a reduced cost compared to what you're expecting. And in the CBS Alliance, we see that operators have put this in place when deploying the services. So what they do is small above ground toilets in areas where you can't dig, like informal settlements, areas with poor soil, dense areas, etc. If it is above ground, you have to empty often. If you have to do this, it makes sense to separate the waste streams and then you get very fresh waste. You don't create waste. It's an input for your next stage, really. And that's very promising. I think that's a great way to think about sanitation very differently, a big paradigm shift. And it's one area where we see a lot of learning from the global south informing what happens in the global north.
Thank you very much, Remy. There are a few questions that are being posted on the chat. Let me advise that we put all the questions in the Q&A and we use the chat for comments. So if you have a specific question to the speakers, please do that. And I will also be looking at the chat to see some specific questions. I see two questions for Karam already, which we will be looking at later. But let's go to Tui now about the introduction of sustainable urban drainage systems. Now, drawing from the Hanoi experience, what do you see as the main challenges of co-opting sustainable urban drainage systems? How can these challenges be overcome?
Yeah, thanks, Pierre. Yes, we suffering from a lot of the challenges on, introducing and implementing the sustainable urban drainage system for Hanoi case study. And I would say that we have some circumstances in the resource availability, for example, the land use, and also in terms of the economy and the social aspects. So looking at the resource availabilities, Hanoi is expanding, very rapidly. So we don't have enough space, to create the new infrastructures. So yeah, there is some challenges on building the separation to sewer, rigs, and drainage system for the new urban area as well. However, we think it's very important, and we gain a lot of the public attention on donating some public space, as well as we try to apply the very innovative technologies and also the compact wastewater drainage system to to reduce and the land requirement. So in terms of the economy, we are lacking the public funding. It is not happening only for Hanoi City, also for other cities, I believe in most of the developing countries as well. So the possible solution that we are trying to do is we gain some interest and investment from the private sectors. And also we try to get some interest and investment from the space owner as well, because we're gonna put some intensive on the wastewater tariff and for some other credits to them to donate and to put the investment on the building the new system for the sustainable urban drainage system. And we're also looking at like the international or partner to implement the partner supports in terms of the economy to implement the sustainable. And, as gestures presented today, we want to apply some like low cost technology and innovation for the sewerage and drainage system. In terms of the social circumstance, we are facing to the public acceptance because a new system, we have to make sure, it's well accepted in the communities. And what we do is we put, them in the education and the training, to train their awareness on, how to apply and deploy the sustainable urban drainage system in their new areas, to understand that, it's a good way for you to look forward to the sustainability development. Yeah, thank you.
Thank you very much, Tui, for that answer. So, Kate, let me come back to you. To Remy first. And Remy, we're talking about the risks that are posed by climate change for urban sanitation. Now, in what ways can container-based sanitation providers contribute to mitigating the climate change risks? And what are there other models we know to be effective for serving climate vulnerable urban communities?
Yeah, climate risks are a big deal, and really we should all be concerned with this. So thankfully, we also know much more at the moment about what the risks are and what we can do. There is a climate resilient sanitation coalition of organizations working on it. And I will put the link later in the chat so that you can see the resources. And when you look at the risks, it's really, there's a lot of them, but really we're talking about not enough water for flushing, for keeping systems functional, and too much water with flooding and contamination going everywhere. To mitigate this, well, there isn't one answer, but there's definitely providing enough options for residents, for urban residents, so that if one system is going to fail, there is something, a fail-safe during the time that there is an emergency. So it's having spare capacity, planning ahead, having, planning for contingencies. And of course, container-based sanitation are above ground toilets, and many of them are movable. So that's one example of what can be done, but definitely not the only one. One thing we're also thinking about is whether sanitation can act as a way to reduce emissions, either because some products can absorb carbon, or because there are ways of doing sanitation that don't produce as many carbon emissions than conventional methods. So definitely the focus should be on adaptation for a lot of countries, but mitigation should be thought about. And the final thing is that one more reason to think about it, if the risks aren't enough for you, is that there's money there. Green Climate Fund has published an annex to its water guidelines specifically on sanitation that says that defines what is climate resilient sanitation, which means if you're a government or if you work with government, you can create projects that can attract climate finance, finally. So there's really no excuse to not think about it.
Thank you very much, Remy, for this. So, Kate, this application of wastewater-based epidemiology and its role in COVID pandemic. Now, can you tell us about WHO's perspective on this innovation? Where and when can it be useful? What are the key guidance to follow in the implementation and monitoring of this kind of surveillance?
Yeah, thanks, Piri. Well, I just want to start by saying, everything we've been talking about up until now has been about, collecting and treating wastewater to prevent risks from wastewater and sludge, affecting human populations or the environment. Wastewater surveillance isn't about that, actually. We look in untreated wastewater or environmental waters for all sorts of things, some of which are transmitted via wastewater, but some are not at all, right? You can just find the RNA fragments there, like COVID, like Mpox, like influenza, like arboviruses. None of those are transmitted via wastewater, but we can find out very interesting things that are happening at the population level in terms of health by looking for those things in wastewater. And there's a lot of pressure to do that now. We have the new pandemic treaty that was signed up a few months ago. And then always this question, is the world, as WHO, too sort of flat-footed when new threats come along? How can we be ready earlier? How can we be more coordinated? And specifically, what role can wastewater surveillance play in that. And what's really clear is that if we look in wastewater for whatever you're interested in, chances are you'll find the RNA fragment in there of that specific pathogen. The real question is, and this is what surveillance is being able to make some sort of public health action with that information. So that's really what we're focusing on. What can we actually do with this data? How does it help us be more ready to respond? And we saw in COVID that was really proven. You know, we saw the confirmation of arrival of COVID into countries that were thought to be COVID-free, the determination of different variants that were arriving, or using the wastewater surveillance to enhance risk communication, whether that was like wearing masks, informing local restrictions, or prompting people to take up vaccines. And this has been done for a really long time in polio. So polio is, you know, quite a disease that's on the brink of global eradication, but only 1% of people carrying polio will have symptoms. So if we can look in wastewater in a population of 50 or 100,000, you can detect one asymptomatic case of polio. So it's super useful to understand where polio might be hiding and to inform vaccine campaigns. And now we're seeing similar things happening on the Mpox public health emergency that's happening now, particularly the distribution of variants and people who aren't getting tested. Similarly for influenza, for measles, some evidence for typhoid and antimicrobial resistance, and some for Zika. It's not totally clear for some of those pathogens, and in some settings, particularly in low sewer coverage settings, whether this is a good investment. So we're seeing the research moving really fast on this, and these specificities of where wastewater surveillance is useful being kind of pinpointed. But particularly what we need to have is integrated systems where we can use a single sample for multiple pathogens to inform multiple different questions. So yeah, I think I will stop there, but just to say that, of course, all of this needs to happen with the coordination of wastewater utilities and environmental ministries. So it needs to be a collaboration between public health and the water sector. I'll pop the latest guidance in the chat immediately after this too. Thank you.
Thank you very much. And just to let the participants know that there's a lot on the chat, so don't miss out. Please go to the chat. There's a lot that is being shared there, and a lot of discussion also going on. We have received 8 questions on the Q&A. 7 of them have been answered, and now there is one asking about biosolids and its application. Can any one of the speakers take on this? Have you been involved with biosolids and its application? This is from Chinmay. Any one of the speakers? No? Okay, so we will respond to that on the chat. But there are also some questions that I see on the chat that we could also integrate, and there's one on the technology. So what specific technologies do you see playing an important role in transforming urban sanitation and wastewater treatment? I think that is going to be the final round, and it's about the innovations and the technologies that we have not discussed so far. So looking into the future, are there any innovations that we haven't discussed which you think have real potential to drive advances in urban sanitation and wastewater management? And which innovation excites you the most and why? So let's take 1 minute per panelist, and these are the concluding remarks also. So Theo, let me start with Theo. You are muted.
Yes, yes. So one of the innovation, we can think of like, like to apply for, the cities and the wastewater and sanitation management is like we can apply the IoT, the Internet of Anything. So Internet of Things, because it's very important for us to, to track and, to see like, what happening in the wastewater system and also in the, urban, in the like fecal sludge management. So Internet of Things is very important, and we can think of like, applying the digital twins. This is, and, modeling, to optimize operation and to predict, what can be the, to predict, the scenarios and, some like, some troubles and circumstances happening during the operating of the system. Yeah.
Thank you, Karam.
So I would say I have in mind an innovative approach that Hamburg Water is also currently applying consecutively, and it's being applied also in other parts of the world. It's called Sponge City, which means, as the title mentions, transforming from a normal concrete-based cities with sealed soil overall, like to this concept of having a city like a sponge that retains, like to increase the retention times and transform normal roads and pavements into a water or rainwater retention reservoirs, which will be used for agriculture, like for the green spaces of the city, as well as it will reduce the hydraulic load and the organic load onto wastewater treatment plants, which means less water or wastewater reaching the plant, posing external and extra hydraulic loads on the operations and maintenance.
Kate, over to you.
Yeah, I have two things. I'm an engineer, so I'm inclined to get excited about technology and innovation, but I actually think the exciting innovations are outside the technology, and I wanted to highlight regulation in particular. With our GLASS data of 120 something countries, I think what we consistently see is that countries that have strong regulatory environments for water and sanitation are making faster progress towards the SDGs. We've recently published a call to action and a roadmap for advancing sanitation regulation. I think this is really key to getting the trust of investors and ensuring sort of transparent progress, working in close coordination with the service providers themselves. So that's one. And then I think another neglected area that I feel bad that we're not working more on as WHO and should be is around the workforce. We see lots of people in sanitation are aging out of it in many countries. But also, I think it's a super exciting field to be working in, and I really hope that we can attract more people who see this as a really exciting professional opportunity to build the workforce we need to manage these services for all. I'll stop there. Thank you.
Thank you very much, Kate. Remy?
Okay. One area where I would love to see a lot more innovation is on emptying and transport of pit toilets and septic tanks and so on. And it's not really about technology. Like Kate, I can be excited about that, but that's not. We need to work more on this because it needs to be a dignified job. It needs to be attractive. It needs to bring regular amount of waste to the treatment plants. Engineers know how to do treatment plants. There's a lot of innovation there, but until we crack the emptying and transport, we won't be able to make them work. So if you want to make a difference, you can work on this. And there's a lot happening, but webinar's finished for today. So be in touch if you want to talk more.
Thank you very much. So I think we are coming to the end of this discussion. I hope that we have captured most of the the questions that were posted by the participants. And we have had very rich experiences from the introductory presentation by Gertrude, the case studies that we have listened to, and also now the expert panel that we have just concluded. I think there are a number of key takeaways that have been highlighted, and I do not want to outline them. We will be sharing all the slides with you. I just want to let you know that as you can see from the screen, you can access the videos, the masterclass. We have hosted them on the UN-Habitat website. You can also access the global report itself on the website, and we will be sharing all the recordings of the webinars, the 6 webinars that we have had. But this is not the last activity that we are having on the masterclass. We plan to have a training on this masterclass during the Global Water Operators Partnership Global Congress that is happening from the 27th to the 30th October 2025 in Bonn, Germany. So if you plan to be in Bonn at that time, there will be an opportunity to train on the masterclass. And I want to thank all the speakers that have facilitated and contributed substantively to all the 6 webinars that we have had, and to thank all the audiences that have actively participated. I have been actually humbled by the number of participants that we have had in each of the webinars. It shows great interest in the subject of sanitation and wastewater. And I wish all of you all the best, and let us keep this discussion going, and we hope to see you in Bonn. Thank you very much for joining. Thank you, and bye.
Thank you.